kind of research and start finding some websites and getting some information. Okay? One of the benefits about these machines as well is you can buy them with just a weld machine. You can also buy them with a built-in air compressor. So they use the engine to help run the air compressor as well. You can get them with, they also produce an alternating current, so you can run grinders, lights, any normal 120 volt applications as well. Plus, both of them are usually capable of running a 220 volt. So again, there's a good backup generator for your home or something else. I've started a car battery on a weld machine, you know, because it's a voltage generators. So I was able to produce a ground, a positive, voltage in between it, set it to 10.5, 11 amps or volts, started it that way. I would not recommend doing that. Determined on the basis of amperage. So for example, this could be a 300 amp machine, it could be a 400, or it could be a 500. Usually depends on there. So there was a classic 300, had all the basic DC power sources versus say an Advantage 500 might have more stabilized arc, more rectifiers in it to help with better arc control and stabilization. And it also may have some capabilities of AC welding, not just DC welding. Okay. So let's talk about the maintenance. Now let's talk a minute about, where's the polarity? There we go. So as you're looking up, I want you to research, find armature and the commutator. I want you to look up and look for brushes, okay? So the brushes, quite often what you'll have to do is they'll wear down, and you'll have to pull them out, change them, 10, 20 bucks for, say, for your grinders, even the same thing. If you own your own machine, it's really important to go through the maintenance manual, start understanding, checking your fluids and so forth. Highly reliable machines if they're well maintained, I guess is the best way I want to put that. All right, let's talk about the polarity switch. So electrode negative and electrode positive used in DC welding. So now we're throwing you for another loop, correct? Okay, so DC electrode negative, that's where the electrode connected to a negative terminal with a power source and the work connected to the positive terminal. So again, the work is what we commonly refer to as the ground. So the ground is on a positive terminal. Now the DC electrode positive, our work, also our ground, is connected to the negative terminal. So this is what most people think of when we think of, hey, it's our ground, it's on our negative terminal. That would be electrode positive, okay? Easiest way to keep this straight is very, very simple. We refer to it as a straight or reverse polarity, okay? So DC electrode negative is a negative symbol is a straight bar versus the positive is the plus sign, okay? So DC electrode negative is a negative bar, straight bar. So we also call that straight polarity, okay? DC electrode positive is a positive. We know that the straight is straight polarity, positive is a reverse polarity, okay? Easiest way, DC electrode negative, straight bar, straight polarity. Okay, you may not always see a DC electrode negative or DC electrode positive when you're pulling out a filler metal box. What you might see is reverse polarity or straight polarity rod. Straight polarity, electrode negative. Negative symbol, straight bar. There we go. Okay. DC electropositive reverse polarity. It's mainly what, 6010-5P, 7018. This is the majority of shielded metal arc welding electrodes we're going to use in here are going to be electrode positive. Now our machines are going to be set up. Some of them will have a switch to where you can go from a reverse polarity to a straight polarity, or you might be able to go DC electrode negative to DC electrode positive. They may not as well. You may have to physically unhook the cables and switch them over. It's also very important, especially starting out, that you go in, you learn how to set the machine up, make sure you're on, say starting out with shielded metal arc welding, we're on electrode positive, reverse polarity. We are going to make sure that our electrode piece is tied into the positive section and our ground cable is tied into the negative, okay? Because somebody may have been in there right before you running DC electrode negative with a gas tungsten arc welding or a TIG rig, okay? So it's important for you to check your setup of your machine each time, okay? Trying to think if there's anything real major. Feel free to read through this, okay? I'm trying to hit the highlight things that I think are very important. It's all good information, but I try to make sure that I'm hitting the stuff that's a common day-to-day situation that we're dealing with, okay? Again, we just talked about dual controls, whether they, you know, we're going to set up and be scratch start, lift start type TIG, but then also DC electronegative or positive, and so forth. And we'll go through this as we're going along. Okay. Okay, welding machines have many designs and many purposes. There's very few machines that you're seeing a lot more now that are a multi-process machine. So for example, I have one now. I sold my big welding machine since I no longer am out running up and down the road welding. Now I have a multi-process machine that I can weld gas metal arc welding, shielded metal arc welding, or gas tungsten arc welding with. Not a big one, still has a good duty cycle. I can weld 332 for quite a while. Never had an issue with it. And it was, you know, $1,000 to $1,400 for a good machine. But the larger the machines, like this one right here, it's probably only going to be used for a couple of things. This one, we had several of these in the shop. We used to call them the old tombstones. They had a rounded top, like a tombstone. But these are, you can do an AC or a DC, but they're usually only good for gas or shielded metal arc welding, I mean. Okay? Let's get into rectifier welding machines. Okay? So this right here is a 300 amp AC/DC gas tungsten shielded metal arc welding machine. You can see there's a bunch of buttons and controls on it. Here's the same thing. Notice this one down here doesn't have that many buttons. It's only got one dial. One little switch here. That's it. Very simple. Okay? Most popular AC's welding machine function and transformer. It steps down high voltage and input current to high amperage, low voltage current required for welding. It's especially suited for heavy work. The AC welding machine, you know, you're going to find nowadays that you're going to have an AC or a DC and or combo welding machine, because most places are expecting you to be able to weld aluminum, stainless, carbon, all sorts of different materials with different processes as well. So I wouldn't say that AC is the most popular, however, for test purposes, that's what they're going with here. We're going to switch to the book, page 294, chapter 11. It's underneath DC transformer rectifier welding machines. Transformer rectifier welding machines, figures 11.9 and 11.10, have many designs and purposes. Flexibility is one reason for their wide acceptance by industry. These machines can deliver either DC electrode negative or DC electrode positive. They may be used for stick electrode welding, gas tungsten arc welding, submerged arc welding, multiple operator systems, and stud welding. All transformer rectifier machines have two basic parts: a transformer for producing and regulating the alternating current that enters the machine, and a rectifier that converts the AC to DC output. A third important part is a ventilating fan. The fan keeps the rectifier from overheating and thus shortening its life. That's very important in most places. Think about where it's at. Don't back the welding machine into a room or throw a coat over top of it. Okay? Make sure that you have the top of the welding machine is exposed. Find where the fan is. Make sure that it can circulate air through there as well, so you don't heat up, burn up the windings, and so forth within the machine. Okay, page 294, chapter 11, right-hand column. We're moving on to the next. AC-DC transformer rectifier welding machines. An AC-DC welding machine is used for stick electrode welding, gas tungsten arc welding, in which alternating current is required for most non-ferrous metals, and direct current is required for stainless steel. The AC-DC welders have the versatility of the DC welder and the special advantages of the AC welder in single machines. Okay, one of the benefits of AC machines is right here. Since you're constantly cycling between a positive and a negative with alternating current, you get absolutely zero, I shouldn't say absolutely zero, you can still get a magnetic arc flow from an outside influence. However, from the machine itself, you get very little arc flow. Arc flow, what happens with arc flow is as you're welding along, it's going to find a path of least resistance. And sometimes you'll be welding along, and all of a sudden your welding arc will just go to one side and just completely just derail and go to the left or right. And especially with 6010 5P, it's very frustrating, especially when you start into the vertical position uphill, because you'll be welding along, and then all of a sudden the arc will go this direction, and you have to force it back this way. You have to take your hand, and instead of it going this direction, you got to force it to go over here and jump that ground over there. A lot of times what you want to do at that point is just stop, maybe reposition your ground. A lot of times you can put your ground on the top, and it'll help smooth things out as well. Okay. But basically what's happened is your magnetic field goes from this big, and as you're welding along, it shrinks up. Well, then it gets more magnified. Okay. And certain electrodes are a lot more susceptible to it. 6010 5P is just prone for a lot of arc flow. You can't get away from it. It's still a highly used rod in industry, electrode in industry, I mean. And it's good. It's a good thing to learn how to deal with as well. Because if you can deal with it, then you'll be aware of it when you run into it in the real world. Go back to the book. Kind of coming back to this. Let's go to the book again, page 296, chapter 11. Page 296, top left-hand column, AC transformer welding machines. The transformer types, the most popular AC welding machine. The function of the current, for example, 120, 220, or 440 volts, to the high amperage, low voltage current required for welding. The characteristics of AC current are such that there's a reversal of current each 1 at 120th of a second. This constant reversal of current keeps the effect of the magnetic field at a minimum, thus reducing the tendency of arc flow. Just what we talked about here, okay? Next page, or same page, next column, right-hand column, DC and AC/DC inverter welding machines. The inverter welding machines are lightweight. Because of this, the inverter is portable and versatile. Inverters may be either constant current, constant voltage, or both constant current and voltage. This means that one machine can perform several different processes. Good example of we've got some XMT304s that are back there very similar to this size. Not real big. They look tiny, but they can put out over 300 amps. Okay? So now we're over to the multi-operator systems. Here we're at the three main areas: the cost of the equipment, operating efficiency, and then maintenance as well. Okay? So this is what we call a bank system. Okay? Multi-operator systems are several welding machines. So when you come up on a big location or say a large construction site, instead of having 8 different welding machines all individualized, they may have one power pack or one bank welding machine system. Bring it in, might even stay on a full trailer, and you just roll your leads out and start welding from there, okay? One of the problems that I've seen with this in the real world is you do start to get a lot of arc blow. You'll get, if all 8 of them are running, you're going to get a lot of different electrical fields and magnetic fields in there as you're welding along. Current output. Amperage range, 200 amps or less for light or medium work. Over 2,000 amps for submerged arc welding. We'll get into submerged arc welding later on. We talked about the open circuit voltage. Duty cycle. Let's talk about duty cycle for a minute. So in your book, we're on page 298, right-hand column about halfway down. Let's read what it states as duty cycle. Duty cycle is the percentage of any given 10-minute period that a machine can operate as its rated current without overheating or breaking down. It's really important. So right here it says a 60% duty cycle means the machine can be used at its rated capacity 6 out of every 10 minutes without damage. So this is, if you're doing shielded metal arc welding, you're going to, after 4 or 5 minutes, you're going to be done with your electrode. It's going to be used up. You're going to stop, take a break, change out rods, pound off the slag, clean your weld, and so forth. Where we really have to be careful is when we're doing flux core, gas metal arc welding, because you can just keep welding and welding and welding. Next thing you know, you're destroying your machine. Most of them have circuit breakers built into them now. Make sure that they're working and everything else. But kind of be aware, after a few minutes, 10 minutes or so, think, man, I'm using that thing quite a bit. Slow down, give it a break if you can, so forth. So 60%, 6 out of every 10 minutes, 40%, 4 out of 10 minutes it can be used without being run. What you really would love to see is 100%, means the machine can be used at its rated capacity forever, right? Well, I don't know about forever, but for long periods of time, for sure. Okay? You can read through effectiveness if you would like, efficiency and so forth. Okay, we're going to go over to cables and fasteners, page 299. Go left-hand column, second paragraph down. It's underneath electrode and work cable. To complete the electric circuit between the welding machine and the work, 2 cables of adequate current carrying capacity are required. An electrode cable, also called a welding cable, is attached to the electrode holder, also called your stinger. A work cable is attached to the work, aka ground. A rubber-covered multi-strand copper cable, especially designed for welding, is generally used. And again, remember, it needs to be designed for welding because it's a high amount of heat that we're putting in. So you want to make sure that the rubberized coating or the conductor over that, the coating over the wire, is capable of handling high heat, grease, and so forth as well. Okay? We're going to skip over to the right-hand column, page 299, right-hand column. We're going to go to the bottom paragraph there. It starts out, the amperage of the welding machine and its distance from the work are important considerations when selecting the size of welding cable. So it refers to you it refers you to table 11.2. If the next page you flip it over, it shows you see if it'll bring it up here. It does not. Okay. Tells you a distance on that page. Okay, so we're at page 300, table 11.2. Welder capacity, so A. So say it's a 300 amp, and then it's got total length of cable being used. So say you're out at 100 feet, 300 amps, you want to be using a 3/0. So the O is what we call an aught, as we're sizing wire and cable. Now come back to the left at 50 feet, 300 amp, we can run a size number 1 wire. Okay. Now look down here at 500. 500 amps, 3/0 for 50 feet. This is this is a very similar amperage that you might be carbon air arc cutting with, where it gets really, really hot and a very volatile amperage. Okay? All right, let's flip back over to page 299, right bottom, right-hand column. The greater the amperage and the greater the distance between the work and the welding machine, the larger the cable size must be. The larger the cable number, the smaller the cable size is. Resistance increases as the diameter of the cable decreases. Therefore, if the cable is too small, it will overheat and affect the welding operation. Resistance also increases as the length of the cable increases. Okay? The welding machine should be set up as close to the work as possible. Welding cables that are too long may cause a voltage drop so great that it has serious effects on the welding current and arc. So sometimes we'd run out 400 or 500 feet on top of a crane or something. By the time you were able to park at one side, you might be 100 foot up, 200 foot up, 200 foot out this way. Well, they had built-in welding cable already on there. All you had to do was pull up, hook into it, and then you just carried your whip, your small electrode holder, your whip or stinger up there, and then you would plug into somewhere close, and then you'd be able to roll out